Hello, welcome back. So this is a two-part video, and we're talking the second part as a follow-up to intent understanding, which included query annotation or tagging and classification. In this part, we'll talk about rewrite or reformulation. Again, this will be a high-level overview of some of these papers, which focus on rewrite. Um, so like Yang 19, Zhao 19, which are more recent, as well as seminal ones like Golapudi 11 and 12. So first we'll start with efficient rewrite for structured queries. Um, Basically, users prefer to see results close to the original query instead of looking at an empty page with no results. As an example, if you give a 50-inch Samsung LED TV, rewritten it will look like 46 to 55 inches Samsung or Sony LED or plasma TV. That's the customer problem. So fidelity of rewrite is measured by distance of results retrieved versus original query through user preferences learned from click logs. Coverage is measured by how often expectation is met when a certain number of results is requested. So the other related problem is structured query reformulation. The technical challenge is that lack of domain knowledge hinders mapping query terms to product attributes. As an example, designer handbags, what's the price, manufacturer or material is considered a designer material. So probabilistic mapping between modifiers, designers in the above example is a modifier, and attribute values based on user behavior and structured data source, which is product catalog. So we need to infer a set of attribute values that best describe the modifier semantics from initial associations used to retrieve product from catalog. So designer results for the query, actual results are shown on the left side. The designer handbags restricted to category women's handbags and purses, retrieved due to the term designer in titles, better results through reformulation. Something like Gucci leather handbags, that will probably give a better result. So that's the crux of query reformulation. The top 10 valid modifiers for the different categories. So terms amongst all free tokens which restrict product retrieval, they help distinguish what a user has in mind. These are called modifiers. For as an example, the TV category, the portable means light in weight. Streaming is a special feature. Handbag, um, the evening is color or material, whereas small is size. So a subset of the modifier category selection criteria is number of queries received, uniqueness, and the top level. So like air conditioner, something like central, commercial, ductless. For refrigerators, counter depth, small, under counter. Wallets is designer, stylish, and so on and so forth. Now association scores, something like a ductless air conditioner, Sanyo or comfort attribute values for quiet dishwashers, Fisher and Paykel, GE, Decor. So there are some, these have high association scores from the past click logs. So now here, like, for the category streaming for Wi-Fi enabled, portable, small under 24-inch diagonal for DVD players and televisions. So now the rewrite queries are obviously better than the original ones. As an example, like 24-inch Whisper Wash is for dishwasher, and wine chiller, beverage cooler for the refrigerator, and small, colorful for the handbag. Now, some more recent work Here, active semantic matching for query rewrite. Query rewrite could change the intent and retrieve irrelevant products. That's a technical challenge. Short queries with limited information, hard to learn matching model with text candidates, cost of labeling for training samples. So treating each query word as keyword causes unintended match. Um, Sorry, there was something else which I forgot to cover in the previous slide. So select multiple sets of attribute value pairs with disjoint attributes to tackle large number of missing or null values in the database. The rewrite is better because sole inclusion of products in concerned category, air conditioner versus books or remote controllers. So query now moving on to the next slide, which is active semantic matching. Query rewrite is composed of candidate generation and ranking phases. Selected candidate queries may affect users' search experience significantly. Now match leveraging logs enhances original or candidate representation, estimates similarity, uncertainty or novelty sampling, because the model estimation is difficult, and the probability of occurrence of new words. So these two are the criteria. So search logs enhance representation of original and candidate queries, as mentioned already, which in turn can be utilized in multi-view attention structure to semantic matching model accuracy, despite short text problem by leveraging sequence information addition. An active learning framework afterwards utilizes fewer samples to improve the model. Uncertainty or novelty sampling strategy selects unlabeled samples by two factors: probability of how hard it is for the model to infer semantic similarity and samples. So next, we need to judge the original and candidate through semantic similarity, optimize matching as a binary classification, maximizing probability of candidates similar to original, the label matching pair with 1, and candidate retrieves product. Semantics of original change the candidate, label pair with 0. Examples like swimsuit covering the belly, one piece swimsuit, label is 1. Whereas bikini label is 0. A warm shirt, plush is 1, summer is 0. Lakers jersey, LeBron jersey is 1, number 23 is 0. So here the intent is below the knee skirt winter, enhance the original and candidate, long rewrite. It gives many relevant products. Wool or cotton is no keyword for winter. Click-through rate and number of newly retrieved products. Long skirt is the best candidate, but some results are irrelevant. So as shown in the figure, a user wants to buy products related to below knee skirt. In addition, she wants to wear it in the winter. Therefore, she types the inquiry with below the knee skirt in winter. However, like title of many relevant products utilize long keywords to replace semantic of below the knee. In addition, many kinds, wool, cotton, can be worn in winter, even though the titles may not include the word winter. In order to retrieve much more products, 3 candidate queries have been generated. Then she clicks 2 products retrieved by candidate queries. From view of CTR and number of newly retrieved products, first candidate query, long skirt, should be the best. However, it also retrieves some irrelevant products, not long wool or not long winter. So another approach is code training with rewrite and match. Several severe vocabulary gap in e-commerce, professional language of product titles, and more like vernacular queries. sparseness of training data. These are the issues. So relevance is the core problem of a search engine, and the main challenge is the semantic difference between user queries and documents due to writing styles, exacerbated in e-commerce in particular. Seller describes commodities in many different business domains, like Kobe 11 Elite, whereas users express their demand by daily vocabulary, something like a Nike basketball shoes. Hard to retrieve with classical text matching models, thus understanding queries and documents and addressing language discrepancy is critical for search engine result page relevance. Um, Recall phase first finds documents which contain all query terms. These query document pairs are fed further into ranking phase, which sorts documents by relevance scores. Rewrite model enhances the query quality in the recall phase, um, leveraging different kinds of information to explore additional documents. Matching model maps queries documents to a common semantic space and calculates their similarity as an important feature in the ranking phase. Click-through data is used as an implicit feedback signal in both tasks, but noisy, biased in an e-commerce search engine. Connection between rewrite and match builds huge unlabeled dataset from logs, iteratively co-train two different user relevance problems. So labeled data generated from unlabeled set. User behavior is influenced not only by query document relevance, but also image, price, and user preferences greatly. As an example, female user searches round collar shirt woman and may click irrelevant products whose title is women casual sleeveless printed vest dresses because the picture is more attractive than a plain shirts. So here the D1, D2 are relevant with Q. So R1 is considered a good rewriting of Q. D3 and D4 are irrelevant with Q. So R2 is a bad rewriting of Q. The original Q is VR helmet, and R1 is virtual reality headset, whereas VR games is not a good rewrite. Whereas label QR3 as good because 2 out of 3 documents retrieved by R3 relevant with Q, virtual reality glasses. Um, Now label QR4 as bad because 2 out of 3 documents retrieved by R4 irrelevant with Q. So 3D glasses is not a good rewrite of VR helmet. That's what defined. So we can do it both ways, either rewrite and match or match followed by rewrite. So another approach is term selection refinement or weighting. So tail or rare queries fail to determine relevant terms representative of query's product intent. So we need to leverage historical query reformulation logs towards distance supervision. Something else I missed out in the earlier slide, rewrite and matching tasks are highly correlated with each other. Good rewriting query always retrieves relevant documents for original query, while documents retrieved by a bad rewriting query are mostly irrelevant. Learned query rewrite model generates 2 rewriting candidates for query VR helmet. Uh, Candidate virtual reality headset is good and VR games is bad. Most documents retrieved by R1 are relevant to Q, whereas R2 are not. Alternately, relevance between docs retrieved by a rewriting candidate and original query decides whether candidate is a good rewriting. Suppose a matching model is learned which evaluates whether a query document pair is relevant. For query VR helmet and unknown element virtual reality glasses, um, because most docs retrieved by R3 are relevant to Q, it's a good candidate with high probability. For candidate R4 equal to 3D glasses, because some document retrieved by R4 are relevant to Q, it's probably bad. So continuing on term selection, refinement, and weighting, what are the technical challenge? Match query terms not relevant to product intent, like socks for running shoes. Different terms in query than description, outdoor versus exterior paint. High frequency, low inverse document frequency weight contribution, like woman versus men's shoes, a striped men's shirt. Importance depends on context or neighborhood. Three-piece kids dinner wear versus men's suit. So terms retained in reformulation more important than those discarded. This is a solution overview. Predict additional terms that describe the intent better. So the architecture or the framework consists of an intent encoder, which learns representation with RNN, feature generator, which captures the contextual information, weight calculator, which estimates term contribution, multi-label classifier, which suggests terms not in the original query. Now, predicted terms for select queries, like initial query is orbit, red garden hose water nozzle, and the reformulated query is orbit hose nozzle. So the model, the FQR is showing that the experiment because Orbit is a gum brand. So like Little Tikes ball for ball pit balls. Um, the first one, the CQR model looks better results. Physical therapy tools for ankle. So like reformulated queries, physical therapy tools. So the product intent in the first example is like water spray nozzle, the brand Orbit, and the color is red. Without context, gum spearmint are predicted in the second example. So Orbit, because Orbit is a popular chewing gum brand. So that's the claim in this paper, leverage the context for rewrite. So another approach is to leverage catalog or knowledge graph for attributes identification. So to resolve conflicts like Maroon 5 DVD, color maroon versus band. For DVD, better be band, right? Significant term items of product type, DVD, band, not color as an attribute. Metrics, probability in query, attribute and value. So that's pretty much what we wanted to cover in the rewrite. So we have kind of concluded this session. We started with tagging or annotation in the first part of the talk for queries, and also classifying queries to categories or stores. In the second part, we are discussing few approaches, how a query can be rewritten to bridge this vocabulary gap. So now we have all these tools at our disposal, active learning and also co-training, transfer learning in the previous portion of the talk. So I think we are pretty much done with this session on neural methods for query intent understanding and reformulation. Thank you.